Alright, when we talk about significant figures, there are certain rules, and knowing those rules is going to be really helpful when you do the calculations. One of the first rule is all non-zeros digits in a number are significant. For example, if it is 1.2, it's non-zero digits, right? So it has two significant figures. The another one, any zero in between two non-zero digits is always significant. For example, if it is 305, it has three significant figures. Now, if the zeros are at the left of the number, they are not significant. Example, if it is 0.00032, you will not count this zero. Okay, so it has only two significant figures. Now, what if the zeros are on the right side? For example, 400, if it is on the right side and if there is no decimal point, it has only one significant figure, so you will not count these zeros. However, if there was a decimal point right here, you will count all the digits. Okay, so it has three significant figures. Now, so if the zeros are on the right side after the decimal point, we will count that as well. 400.00, how many? It has five significant figures. Okay. Now, how to round to the correct significant digits? For example, I have this number 37.9832 and I need these in a three significant figures. How can I do that? I will count here 1, 2, 3, right? Because I need only three sig fig, I can draw a line here and I will see the next number is 8, right? So I will add 0.1 to this digit. So when I do that, it is going to be 38.0. Remember, it needs three sig fig, so I'll have to put 0 and the 0 after the decimal point is significant. So it has three sig fig. So what about this one? I need two significant figure. These 0, they are not significant. So now 1, 2. Okay, so I can draw a line here, but the next number is 4. So I will leave it as 0.037. Okay, and for this one, I need four significant figures. 1, 2, 3, 4. I can draw a line there. So the next digit is 6, which is greater than 5. So here I will have 1, 2, 5, 7, 0. Okay, so you cannot leave as 1, 2, 5, 7. Okay, because it needs to have same scaling as the equation. Alright, so what about this one? I need two significant figures. I cannot, if you write this like 90000, this is wrong, okay, because it has only one significant figures. So in order to make it to 2, what I can do instead, I can write 9.0 and put it in a scientific notation. Okay, so this is 2 sig fig. So this is a large number, okay, 90,000, so it should be positive. Now for multiplication and division, it is pretty simple because you can actually determine the number of significant figure before you do the calculations. Okay, because the final answer cannot have more significant figure than any of the original numbers or from your questions. I'll give you example. If it is 2.135 times 3.14, if I do this in my calculator, I will get 6.7039. So now the first thing what I will do, if I see the multiplication or division questions, I will look at the significant figures from the original number or from the question. Okay, this one, it has 1, 2, 3, 4, 4 sig fig. This one, it has 3 sig fig. So my answer can have only 3 significant figure. Okay, so that's the lowest one among these two. So 1, 2, 3. I'll draw a line there, and the next number is 3, so I will leave it as 6.70. Okay, so it has 3 sig fig. Now, for addition and subtraction, you cannot determine the number of significant figure before you do the calculations. Okay, and your final answer can only be as precise as least precise value. So what does that mean? I have this example. When I add this, I will get 11.295. So now I will look at my questions. Okay, so it has 3 digits after the decimal point, and it has 1 digit after the decimal point. So my answer can have only 1 digit after the decimal point, which is here. So now I can draw a line. The next number is 9, so I will write as 11.3. Okay, so if there is no decimal point like this, what I will do, I will write them over here like this. So now these 2 zeros are not significant, so when I add, it will be 145. Because these 2 zeros are not significant, I will draw a line here. Okay, so the next number is 4, so it will be 101 sig fig. The next one I will do like this. Okay, so 120 here. When I subtract, I will get 6665. Because this 0 is not significant, I will draw a line here. The next number is 5, so I will get 6670. Okay, I'll give one more example. 15.1, 130, 2.45. Now, there is no decimal point in this number. Okay, so in this 0 is not significant. I will draw a line there, and I will get 147.55. Because my line crosses here, I can have only 2 sig fig in my answer. The next number is 7, so it will be 150. Okay, so it has 2 sig fig. For mixed calculation, okay, so it has multiplication and subtraction. I will do whatever is inside the parenthesis, that one first. Okay, so when I do this in my calculator, I will get 0.124. But remember the rules for addition and subtraction. Okay, so this one has 3 digits after the decimal point, and this has 2 digits after the decimal point, right? So my answer can have only 2 digits after the decimal point. However, the very important thing is you cannot round until you finish the questions, okay, until you finish the calculation. So inside my head, inside my mind, or somewhere on side, I will write this as 0.12, okay, because the next digit is 4, so it will remain like this, and it has 2 sig fig, but I will not round up. Okay, and when I multiply with the next number, I will get 5.75310. Now I will count this as 2 sig fig, and it has 5 sig fig, and in multiplication and division I will write the lowest significant figure. Okay, so I need to change this to 2. So 1, 2. The next number is 5, so it will be 5.8. Okay, 2 sig fig.